So we'll head down to problem 1. Try to leave that up there as well. So problem 1 says let f of x equals f of 5x cubed plus 1. So this represents the function rule for f of x. And then g of x equals x squared minus 4. So that x squared minus 4 represents the function rule for g of x. Now it wants to know what is f plus g and then f minus g, and we're going to hold off on the domains. So where it says f plus g, this is going to mean take the function rule from the f function and add the function rule from the g function. So first, the f function rule is 5x to the third plus 1. Then we're going to add to that the g function, and I'm just going to use color coordination here. So g function is x squared minus 4. So what that is communicating to me, and this is a big section just kind of working on the communication, is take the function rule from f, 5x to the third plus 1, and add it to the function rule from the g. And then once you get it set up, we're going to do any simplifying we can, and then we're always going to put our final answer into standard form, which means highest degree variable first all the way down to lowest degree. So the only thing that we're seeing here is a plus 1 and a minus 4, which is going to simplify to a negative 3. So we're going to be left with 5x to the third. That's going to be a positive x squared. And then a 1 and a negative 4 are going to make negative 3. And then there's my final answer in standard form. And that's it. And when you're typing these into Delta Math, remember to use Shift 6. That's going to get your exponent. And that's going to be how we can add two functions together. We take the function rule from each one, add them together. Taking a look at problem 2, we're going to subtract f minus g. So we're going to have a 5x to the third minus, plus 1 minus, now since I'm subtracting a binomial, two terms, I'm going to group those together. So it's important when we're subtracting a term or a function rule that's more than one term, we want to group that together to make sure that we're subtracting everything in that function rule. So here now we're going to start to simplify. So 5x to the third. Then I look here, I've got a minus x squared. I subtracted that x squared. Now we get to combining like terms. So if I'm going to be combining 1 minus a negative 4, that's really like adding. 1 minus a negative 4 is adding, so 1 plus 4 would give me 5. So my two functions subtracted would give me 5x to the third minus x squared plus 5. So once we get our two function rules subtracted, we make sure it's in standard form, and then we make sure every possibility of terms is combined, and there we get our final answer. So with those first two problems, adding and subtracting, are there any questions, comments you guys have? Anything that you need clarification on? All right, you guys ready for some multiplying and dividing? Okay, here we go. Let's head down to problem 2. So we'll take a look at just the A and the B. So we have two new function rules. F of x has a function rule of x squared plus x minus 6, and then g of x has a function rule of x minus 2. First thing we're going to do is multiply the two function rules. So my function rule of f is going to be x squared plus x minus 6. And we are going to multiply that by x minus 2. So I'm going to group together this function rule. And then my blue is going to be my g of x function rule. And I'm going to group that together. And there's our two function rules that we are going to multiply together. Now, as you're starting to look at this, we are multiplying a trinomial times a binomial. So we're going to have to do some distributive properties. So the x is going to be distributed out once, twice, 3 times, and then the negative 2 has to go out once, twice, 3 times. So we'll start with the x. When the x goes out to all 3 terms, we're going to get x to the third plus x squared minus 6x. Okay, so there's going to be our x distributed out 3 times, and then negative 2 gets distributed out 3 times. So negative 2x squared minus 2x plus 12. So there's going to be my x distributed out 3 times, and then my negative 2 distributed out 3 times. After that, we look to combine like terms. So x to the third, there's only one term, that's x to the third. X squared and a negative 2x squared would give me negative x squared. So I'm just thinking of that. There's a 1 there. 1 minus 2 brings me down to negative 1. Negative 6, negative 2 gives me negative 8x plus 12. All right, so there's going to be my two functions multiplied together, and then this would be my final answer. Take the two function rules, multiply them together. Now we look at dividing. So dividing my two functions, I'm going to start with my f function rule, because I'm doing f divided by g. I'm only going to do b, and then the other one's just the reciprocal. So once we have b, we'll have c, because it's just going to be the reciprocal of whatever we get here. So x squared plus x minus 6, we're going to divide that by x minus 2. Now, anytime we have a fraction, like if we have a fraction like this, 9 twelfths, what could we change 9 twelfths into? What would 9 twelfths simplify down to? 3/4, right? That's what you're going to say, right, File? Oh, Gavin, I'm sorry. Your little green things are right next to each other. Sorry. Thanks, Gavin. So 3/4 would be what that simplifies to. But the moral of the story is fractions, they might have some common factors in them that we can simplify down. When we're dealing with polynomials, and we'll find out in chapter 8 when we get to that this is called a rational expression. It's a fraction with polynomials in it, that they might have some common factors. And the only way that we can find out if they have common factors is to factor all possible polynomials. Now my denominator, x minus 2, I cannot factor that one any further, but my numerator is a trinomial. And trinomials are always going to factor into two binomials. And this is a trinomial with an a term of 1. So that's going to be the number riddle where we're going to try to find two numbers. I know that the first two values of my binomials are going to be x and x, two numbers that would multiply to negative 6 and then also add to 1. Well, that's going to be plus 3 and then minus 2. So that's going to factor into x plus 3, x minus 2. And that works because negative 2 times 3 is negative 6, and then negative 2 plus 3 is positive 1. So those are my two numbers I'm looking for. Then we start to look again. Now, do they have any common factors? Well, with numbers, we can kind of tell. Well, 9 has a common factor of 3. We divide it, it makes 3. 12 is a common factor of 3. Divide it, it makes 4. With polynomials, we have to actually write out the factors, and now we can see, okay, there's an x minus 2 here. There's an x minus 2 here. And anytime we have two of the exact same factors, we can simplify that out. So all in all, the f divided by g is going to give me x plus 3. And that will be the final answer. And if you would put this answer into Delta Math, that's going to tell you that your answer is not simplified. So you will need to look to factor, and then they're set up to where you're always going to have some things that are going to start to cancel out. Now g over f. G over f is just the reciprocal. So that last problem there we can do rather quickly. So f over g gave us x plus 3, and anytime you have a plain number, or here we just have an expression x plus 3, you could always write it over 1 and it's not going to change the value. So then the reciprocal of x plus 3 is going to be 1 over x plus 3. So that's going to be my answer to g over f, which is part C on our notes there. So there would be how we can add, subtract, multiply, and divide our functions. So remember, just you got to pick out where is that function rule, and then that's going to be what you're going to use in your operation. So you can add your function rules, subtract them, multiply your function rules, or divide them. Well, that brings us to 10 o'clock. I will stay on if anybody wants to stay on to see a couple examples from Delta Math. Otherwise, you're free to go to work on your own. We'll start with problem 3 tomorrow, looking at composite functions tomorrow. But you are free to break off if you want. This lesson was recorded, and I will be posting it to